Okay, let's go back and talk about the differential again. All right, so say you have a function, y equals f of x. It could be any function that can be differentiated, meaning you can find the derivative of it. All right, then f prime of x, that is the slope of the tangent line to that function, whatever kind of curve it is equal to the change in y. Oops. So the change in the value of the function, that could say df of x. D means change. It's delta, really. Delta x or delta y or delta anything always means the change in that thing. All right? So dy, that's the change in the value of the function, that vertical change. Like I said, it could say d of f of x because y equals f of x. Y represents the function in this case. The denominator is the change in x, okay? Dy, the change in the value of the function, divided by the change in the value of x, and that just means the horizontal change. As you're going along the x-axis or the horizontal axis, if you go from one place to the next place, that's some change, some numerical distance, all right? So that's in the denominator, and then in the numerator, you have the change in the value of the function, okay? So it could say df of x over dx. And so by the multiplicative property of equality, then the derivative, or the differential, what Leibniz called the differential, is dy. So you're multiplying both sides of this equation by the denominator on the right side, dx. So dy is equal to f prime of x dx, that's the differential of y, all right? So if you have a function, y, or f of x equals 3x to the negative 2 plus 2x squared plus 1, and you want to find dy, then you just remember that, that you're finding dy dx. Okay, the change in the value of the function divided by the change in the horizontal change, all right? And that is going to be the derivative. Okay, so the derivative of this function with respect to x, because x's are the things you put into this function, all right? So that's going to be negative 6x to the negative 3 plus 4x plus 0, all right? And if you want to just know what dy is, you will multiply both sides of that equation by dx, and you'll get dy equals negative 6x to the negative 3 plus 4x dx. Okay, that is when they ask for the differential, dy, or d whatever. That means they're just asking for the differential. All right. Okay, just a second. Okay, so when you're talking about the product rule, now you're talking about when you have the product of two functions. And this is when it becomes confusing because now you're talking about two different functions that are being multiplied together. So f of x and g of x, they could be, any kind of function. Now you want to figure out what the derivative of that function is. There's a special rule for that because it doesn't work. You can't just multiply the two derivatives. All right, so you have to use f of x, g prime of x plus g of x, f prime of x. And so when you do that, say you want to find this fg prime of x, then you have to do that special rule. It only works that way. All right, this is where it gets tricky because both functions may not be in x. In this case, they both are in x. They are in terms of x. That is, you put x's into these functions and you get out f of x and g of x. But in some of the problems, the two things that are multiplied together may have different letters than x's in them. And that's when it gets confusing because sometimes you're not remembering that you're talking about the functions themselves. So I'm just going to do some examples where you have to find that differential, but hang on just a second. Okay, so if you have a function f of x equals y equals u times v, all right, you've got two functions here being multiplied together, right here, u times v. And those two functions could be anything. I mean, u could be x squared, or v could be y cubed plus 3, or whatever. They're two different functions that are being multiplied together. All right, so when you find the derivative, you have to use this rule, this product rule. So you're taking the first function and you're multiplying it by the derivative of the second function. And when I say dv dx, okay, I'm saying the change in the value of the function divided by the change in whatever kind of things you put into that function. I mean, it may not always be the letter x. That function may not be in terms of x. So this bottom thing here, it's the change in whatever kind of things you put into that function. All right, and then over here you've got the second function times the derivative of the first function. And again, it's the change in the value of the function divided by the change in the value of whatever kinds of things you put into that function. So maybe another letter besides x, but that's just giving you, they're calling it x because that's usually what the horizontal axis is. All right, so this is where you get kind of confusing. All right, now the differential, all right, so this is the derivative. This differential of a product looks like the differential of this product of functions, two functions multiplied together, is going to be the first function times the differential of the second function plus the second function times the differential of the first function. All right, so this is where things get a little bit tricky with all the letters. That's where you're getting a little bit confused. It's a different. Okay, so here's when it gets tricky. You're trying to find the differential of this s. All right, s is made up of two functions multiplied together. X squared is one of the functions. The other function is y cubed. The second function takes things that look like y's. So you put in some value of y and you get a value of the function. And so when you look at the y here, you have to remember that's acting like it's the domain of this function. It's the stuff you put into the function. You put in y's and you get out a value. So that particular function is a completely other function from the x squared function. You put y's into that function. You put x's into this function, the x squared function, okay? So when you find ds, that is the differential of this thing, you have to do what it said earlier. That is, you have to find the differentials of these two functions. And then to find the differential of s, you take the first function times the differential of the second, plus the second function times the differential of the first. All right? So first let's find the differential of x squared. All right? So you've got d dx of this function, x squared. All right? So this is the derivative of that function. That would be 2x. All right? The reason we have dx on the bottom here is because that's the kind of stuff you put into that function. You put x's in. So change in the function, that's in the numerator, change in x squared as the kinds of things you put in, the horizontal things, the horizontal axis changes on the bottom, dx, okay? And that equals 2x. So just d of that function, the differential of that function, if you multiply both sides by dx, is 2x dx. So that's the differential of this first function, x squared, all right? Now, the differential of the second function, y cubed, that's d dy of this function. All right, the reason we have dy on the bottom is y's are the things you put into that function because it's y cubed. You're taking a number and you're cubing it, and those numbers in this case are called y's. All right, so the derivative of that function, d dy of this function, is 3y squared And then if you want just to know the differential of this function, that is d of the function, dy cubed, is 3y squared dy. Okay, so these are the differentials of these two functions here, this one and this one. So to find ds, what the thing said to do, what the formula is, the product rule for differentials, not derivatives, differentials, is you take the first function, x squared, times the differential of the second function, which is over here, 3y squared dy. And then you take the second function, which is y cubed, and you multiply it by the differential of the first function, which is 2x dx. So the ds is 3x squared y squared dy plus y, or 6x, sorry, that is not right, is 2xy cubed dx. Okay, so here's another one. Y equals sine squared sine t. So you have this function that is a product of two other functions. This function is s squared. This function is sine t. Okay? This first function, s squared, takes s's. You put s's into that function. The second function, sine t, you put t's into that function. Now they're asking you for the differential of this function y, which is made up of the product of two other functions. All right, and the way we do that is we take the first function, multiply it by the differential of the second function, and we take the second function and multiply it by the differential of the first function. So when they say to find dy, they mean just the differential of this function. So the first thing we have to do is find the differentials of the two individual functions. All right, so the differential d ds of this first function, okay, that's what I'm going to find in a second. This is actually the derivative of this first function. D ds means change in the value of the function divided by the change in the value of the things you put into the function, which are s's. That's the derivative. That is 2s. All right. If I just want to know the differential of this function, I multiply both sides by ds. So the differential of this function, s squared, is equal to 2s ds. If I want to know the differential of the second function, first I'm going to take the derivative of the second function. So the derivative d dt of sine t. So dt is on the bottom because that's the kind of stuff you put into this function, t's. That's the horizontal axis. So the derivative of sine, we know, is cosine. And then if I just want the differential of this function, I multiply both sides by dt. So the differential of sine t is cosine t dt. All right, so now I have the differentials of my two functions. That y is, that other function y is a product of those two functions. So now I'm going to find the differential of y, dy. That equals the first function, which is s squared, times the differential of the second function, so that's over here, cosine t dt, plus second function, which is sine t, times the differential of the first function, which is 2s ds. So dy is equal to s squared cosine t dt plus sine t, 2s sine t ds.